Hello and good afternoon, everyone. This is Dr. Prahlad Chaudhary. I am very glad to start the today's session. We are now reached the fourth day of International Faculty Development Program on Advanced Methodology for Contemporary Research, a Pragmatic Approach. Respected resource person, principal, and all ladies and gentlemen who have joined from across the country and from different countries. Now I request Professor Syed Rahmatullah to formally welcome all the participants and start the proceedings of the day. Over to Syed Rahmatullah.
Happy afternoon to everyone. With the new day comes new strength and new thoughts. We are on the fourth day of our FDP program. I welcome all the participants and today's resource person, Professor Girish BN. Girish sir's qualification goes MCOM. He is PGDPA and he is qualified with NET. Girish sir has rich teaching experience of 20 years, handling both UG and PG courses. He is a visiting faculty at prestigious institutions. Girish sir's doctoral research is in the area of Indian financial market. He is currently pursuing that doctoral research at St. Joseph Research Center, which is affiliated to Bangalore University. Sir has a rich interest as well as knowledge in the field of econometrics, and he has attended lots of workshops, and he is having a bundle of knowledge on the financial markets. And sir has also done a short-term course from IIT Hyderabad, which is on applied financial modeling. And sir is also qualified with the NCFM NSC course on financial markets, which is an advanced module from NSC. Girish sir PhD topic is on study on the market efficiency of the stock markets and forex markets in India. So by understanding this topic itself, you can find out what is the depth of knowledge sir has got in the field of econometrics and market, stock market and forex markets. And Girish sir has presented and submitted several research papers in various national, international level conferences and seminars. On behalf of Government Ramnarayan Chellaram College, staff, principal, on behalf of everyone, on behalf of the participants, I welcome you to this session for the fourth day. And the topic for today's session is Introduction to Empirical Modeling and Application of Time Series in Business Research. I welcome you, sir.
Thank you. Thank you, sir.
I take the pleasure to welcome our beloved principal, Dr. B. Chandrasekhara sir, who is inspirational in conducting and organizing all these type of FDPs. I welcome Professor Chandrasekhara sir, principal of our college. I also welcome the organizer of this FDP, Dr. Ijaz Ahmad Khan sir, who has taken lots of efforts in organizing this FDP. I welcome Dr. Ijaz Ahmad Khan sir. I also welcome IQSC coordinator, Dr. Prahlad Chaudhary sir, who is the man behind in all our FDPs and all the programs in our college for effectively and efficiently managing all this. He is always a guiding source.
Now I request Professor Girish sir to take over the session, and I welcome all the participants and we all hope that there is a good learning, and let's develop a passion for learning. We have a wonderful resource person for today's session. I welcome you, sir, and kindly take over the session. Thank you.
Thank you very much, Rahmatullah sir, for your kind introduction, as well as good words about me. Is my video feed clear?
Yeah, it's clear.
Yes, yes.
Audio, sir?
Yes, sir.
Audio and video both are clear.
All right. Very good afternoon to all professors, dignitaries, elders, my fellow colleagues, as well as participants from across the world. Allow me to call you all my dear friends. With all your permission, I would be referring you all as my dear friends. Now, at the outset, I thank Government Ramnarayan College of Commerce and Management for giving me an opportunity and a coveted platform on which I could pitch in my thoughts, share whatever little bit I know about various aspects that I was introduced to and exposed to during the entire journey of my research. I feel quite privileged as I'm standing on this platform of RC College, because RC College is, as you all know, Karnataka's premier higher educational institution that has catered to, that is focusing on, that is contributing to the holistic development of students with particular focus on socially and economically challenged sections of the society. So it is this thought that has made me to feel quite special to stand on the platform given by them. I thank the entire college, principal, staff for giving me this opportunity. Without wasting much of a time, which we do not have, unfortunately, we would be moving on. Is it not audible? I suppose it is audible. I suppose it is. Please check your, yes, yes. Please check your connection, sir. So with that, dear friends, I've already taken your permission to refer you all as my friends. So in this entire process of my research, I have observed that empirical modeling as such is used, is applied only by certain disciplines, only by researchers of certain disciplines, such as science faculties, researchers, economics faculties and researchers, and top educational institutions such as IITs and IIMs. Generally, I have not found, I am using the word generally, I have not found commerce people and other humanities people using empirical modeling to the maximum. And now I have not come across such things in my limited exposure. And this has made me to start thinking about the concept. Why is it so? Because empirical modeling, as far as I know, is a very simple statistical tool which will enhance your research findings, which will give a lot of empirical support to the claims and the validations that you people do in your research. The more empirical modeling you do, the better would be your research prospects. Particularly, it is also good if you start using empirical modeling on your scientific papers. Yes, sir. There is a question, shall we disable chat box? And the answer is yes, for the time being. Whenever I make a request, kindly enable the participants to post not only their queries, but also many other things. I'm coming to that. All right, dear friends, as I was telling you all, that empirical modeling is not used by many of the researchers. And that is something that puzzles me a lot. Now, when I started applying empirical modeling, now by default, I'm supposed to use empirical modeling as my data, my area of research is secondary in nature. However, I think I'm hearing a lot of background noises, Azad sir. All right.
Sir, you can continue. It was unmuted.
Yes, sir. Yes, sir. Yes, sir.
Sorry.
No, it's okay. All right. Dear friends, I was telling you all that the more empirical modeling you use, the better would be your research findings, the better chances you will have in getting your paper selected for publication, as well as for paper presentations at various conferences. And it is not that we need to have a very complicated understanding about empirical modeling. We need to present our research findings in a very complicated way. The answer is absolutely no. Another very simple question that I keep getting in all my presentations is that, do we require a science background? And the answer is absolutely not. Should we be very good at statistics? The answer is absolutely no. Do we need to have studied empirical modeling in your PG? And the answer is absolutely no. Why? Because empirical modeling itself is such a topic which grows along with you and with your knowledge. The more you learn, the better would be your prospects of applying the same. And that is what I will be ensuring in today's and tomorrow's presentation. Now, I would also like to share with you all the structure that we have devised when this issue of finalizing the topics came. I requested, sir, that we need to have at least 3 days time for basic application of modeling. Accordingly, the organizing committee agreed to it, and here you are. Today, you shall be given an introduction about empirical modeling, and tomorrow it would be on application of time series, another very important area of research that majority of the commerce faculties and other humanities, except economics, do not generally use. So we thought that let us focus on these two for the next 2 days, and on the next day, that is on the third day from today, we shall be focusing on panel data, where yesterday I could see that there were a lot of questions to Ishani ma'am about the way in which bank data is to be analyzed, and the answer is panel data. That is how we have completely structured it. Today it will be an introduction, tomorrow it will be a little bit developed version of modeling, and the day after tomorrow it will be advanced application of modeling, which is called as panel data econometrics. With that note, permit me to start sharing my presentation, dear friends. One second. All right, with that, dear friends, I take this opportunity, privilege to welcome you all to the fascinating world of empirical modeling. Now, at the beginning, I would be making an assumption, a hypothesis rather. Now, we are all researchers and we are fond to make assumptions. And that assumption is that the audience do not know anything about empirical modeling. Now, this basic hypothesis of mine would help me a lot in sharing whatever little I know, and in also developing a sense of understanding that audience will be taking away whatever I am telling. So with that note, let us begin with this empirical modeling. So let's move on to the first thing, and that is what would be the outline that I would be covering today. Now see, today we shall be doing various things which will help us actually not to learn anything new, but to prepare for tomorrow and day after. So today's entire presentation, my efforts would be to focus on making you all understand the intricate aspects of modeling, as well as to sensitize you people towards certain basic aspects that are generally ignored by researchers when they are doing modeling. So that is what exactly we will be doing. On a serious note, I would be starting with types of research a little bit, and then I would be moving on what exactly is empirical modeling, and then I would be introducing the concept of regression, and then I would be starting with population regression function, something that generally is ignored by researchers. And then I would move on to sample regression function, and I'll explain the concept of alpha and beta. With that understanding, I'll take you to a hypothetical case that I have designed exclusively for this particular workshop. It's completely based on data simulation that I have done. It's a case rather, but the data is completely a stimulated data. That means it has been created by me and it has not been collected anywhere. Nevertheless, we would be applying the regression technique on that particular case that I have developed, and which would definitely allow you people to have an understanding about what exactly is regression and what exactly is empirical modeling, how to move about this empirical modeling. All right, so let's move on quickly with this. What do you exactly mean by the term empirical research? Now, empirical research, as the very name suggests, refers to a type of a research that is completely focused on the feasibility of a solution using real world data. Here, we don't generally use any theory as such. We don't use a context as such. Rather, we would start identifying a problem, and then we would be using the available data from the world, from the surroundings around us, and then we would be trying to come out with a solution, a feasible solution, which would completely be based on something called as evidence. Now, the empirical research, the entire concept, the entire foundation of empirical research lies in evidence. For everything, empirical research demands an evidence, be it data collection, be it data sorting, be it data scaling, be it data analysis, be it finalizing your conclusions, and be it testing this entire solutions that you have come out with. Everything in empirical research is completely based on evidence, and that is what has made this empirical research a very celebrated type of a research. Now, what is the difference between a conceptual research and empirical research? Now, in certain disciplines, we use conceptual research. Even in statistics, we use conceptual research, which we call as theoretical research. And empirical research predominantly differs from conceptual research. How? The first thing is, it's a type of research, the meaning is totally different, which is generally based on abstract ideas and theoretical concepts. It can be an idea that comes up in the mind of a person, which would eventually put up into a research design. But empirical research is not like that. It is based on verifiable evidences. What do you mean by the term verifiable evidence? The evidence that you collect, the data that you collect, will be based on an observation. It will be based on an experience that you would get by getting exposed to that research problem as such. Now, in case of a conceptual research, generally abstract ideas that cannot be practically experimented. Now, if you come across the virtual significance of an art, many a time we may end up getting confused rather than to exactly understand what that artist is telling. That is because he may have an idea and he may have to work on that idea. He may have to build a model. He may have to build up a theory based on that. Therefore, it all comes with an abstract idea. Why it is abstract? Because it is not exactly refined. It is still an idea. That is why we call it as an abstract. But in case of an empirical research, we always dwell on a very important concept, and that is a phenomenon. A phenomenon here refers to a happening in the nature, which may or may not have an explanation. Many a time for the things that happen in the nature, we will never have an explanation rather than to experience that thing. We can never have explanation to the changes in the climate. We can never have explanations, probable explanations to the things that keep on moving around us. That includes various phenomena. And as a researcher, we generally need to identify a phenomenon, understand the phenomenon, relate your research problem with that phenomenon, or pick up a research problem with or in that phenomenon, take it out and start researching on that. Why is it so? So these questions, why, how much, when, is always done in empirical research. All right. Now, what is the methodology that we adopt in empirical research? In empirical research, we use completely formal methodology of doing the research. The research design would be completely formal, and it will never be an informal thing, and it cannot in any way be a contingent thing. Contingent thing is something that can be changed at any point of time, but in empirical research methodology, nothing changes, and it needs to be followed on a step-by-step process. It is a process. Now, the entire research design focuses on the first step, and that is called as observation. We observe the phenomenon, as I told you earlier. We observe the things that are happening around us. We tend to identify a problem based on a review of literature or on some sort of a gap that we may identify. And many a time, there might not be a review of literature, but still we may end up identifying something, a problem rather, which of course comes from your observation. You need to start observing and meditating on that phenomenon. That is when we get a thought. That is when we get a question. And the beginning stage of empirical research is always a question. Once when we develop a question, when we observe the things, then we may use any one of the two very important techniques of understanding that phenomenon, and which is generally used in psychology. One is induction and another one is deduction. Two completely different methodologies may be adopted by us depending upon the problem that we choose. Further, whether we move out with induction or with deduction, the next stage will be the testing of it. Testing of the data, testing of the solutions that we may have found out of the data, and then we move on to evaluating the solutions. Generally, because we may not get one simple solution, we may get several solutions, we may get several alternatives of a problem, and empirically we identify which is the best objective, best alternative that fulfills our objective, and we evaluate that and we finally select it. This is what we do in empirical research methodology. So what is the difference between, some thought may have come up in your mind, Girish, can you tell us the difference between deduction and induction? And the answer is, in case of an induction, we induce our understanding to a phenomenon. So the beginning stage in induction methodology is that we observe. When we observe something, then we will be able to identify a pattern. Girish, what do you mean by the term pattern? How can we identify a pattern? Now, please remember this particular thing and underline this, and you will get an answer in my tomorrow session, how to identify patterns in share prices. Because our entire time series analysis is based on identifying patterns. Mind you, my dear friends, every phenomenon in this universe has got a pattern in it, and we researchers need to identify that pattern. That is where the researchers fit in. So we will identify a pattern. Based on the pattern that is already there, we develop our understanding, which is called as tentative hypothesis. Based on that tentative hypothesis, we apply certain statistical tools. We may validate that hypothesis. And based on that, we will get certain inferences or conclusions. And based on such conclusions, we come up with our own theory, CAPM model. On the other hand, we have deduction, where we deduce an understanding out of something which is already there. There would already be a theory. For example, when we speak about diversification, investment portfolio decisions, we know that there might always be a set of people who are risk averse. there is a theory. In behavioral finance, we have a lot of other theories. You have heuristic behavior. Now, based on that, any one particular theory that interests me, I tend to create a hypothesis based on the research gap, based on the review of literature. After framing the hypothesis, I start observing my sample population, and then by the behavior of the sample population about the problem that I have identified, I draw certain conclusions, which we call as deducible theory. Now, in empirical modeling, definitely we use induction as well as deduction. How we do that, that entirely depends on the research question that we frame and the data that we come across, which is absolutely not in our control. Quickly moving on, I will not take up a lot of time on that because Dilip sir has, in the most extraordinary way, has explained the concept of various methods of research, and Ishani ma'am too has explained various types of research. I request you to focus only on one thing, and that is descriptive research. Now, all empirical research methods, that is the research which is based on a quantifiable data, can be broadly classified into two categories: descriptive research and experimental research. When you try to describe a phenomena which is already there, which is right in front of you, which people know, they know the phenomenon, but they do not know how that phenomena is working, then that is called as descriptive research. On the other hand, you have experimental research where the cause and the effect will be verified by a researcher for the first time, where there wouldn't be any review of literature, past research as such in that particular area. So it is completely a walk in the thick forest with completely blindfold. So that's exactly as experimental research. We'll not be focusing on that because generally in social sciences, we take descriptive research. Now, in descriptive research, we classify various types of research into two broad categories. One is quantitative and another one is qualitative. How and why? It all depends on the variables that you choose for the study. If the variables that you choose for the study can be quantified, which can be measured in terms of numbers, which can be arranged, which can be recorded, which can be taken down, which can be observed in terms of numbers, in terms of quantity, then that study becomes a quantitative study. On the other hand, when it is very difficult to identify the variables and generalize the variables or measure the variables, but only can have an understanding about the variables, then we call it as qualitative study, which is more focused on emotions, feelings, and all those activities that cannot be effectively measured in terms of numbers. Once again, our focus will not be on qualitative. In quantitative, there are several types of research, which definitely I will not be taking up, but I would be taking up a very important type of a quantitative study, and that is cross-sectional and longitudinal studies. My dear friends, today and tomorrow, I shall be talking about cross-sectional and longitudinal studies, and day after tomorrow, Dinesh sir, a celebrity in North India, will be speaking on something called as panel or pool data. Before that, what do you mean by the term cross-section? A cross-section study is a type of a research where you can gather, you can observe, you can collect information in the form of the data from various subjects. What do you mean by the term subject? Your focus study. That focus study can be one variable or it can be several variables. But the point here is you will be collecting data from several variables which are called as subjects by fixing the time of collection and the time of observation. So at a single point of time, if you collect the data from either one or with a large number of subjects, we call it as cross-sectional studies. On the other hand, in a longitudinal study, we take one subject or one group of subjects and we study the changes in the behavior or the values in that subject over a period of time. So in cross-section, time is fixed, but in longitudinal study, time is continuous. Along with the moment of the time, you will observe and you will collect the data about your subject. Once again, I am using the word same subject over a period of time, maybe for 1 month, 2 months, or maybe for a period of 1 whole year, or for a period of 5 years, 10 years, 15 years, 20 years. You will be collecting the data from one subject. Now that subject can be one single variable or one group of variables having the same attribute. Now, longitudinal studies are also called as time series studies because the series of changes that have happened in the subject would be studied at different point of time by collecting it. Therefore, when you collect the data at single point of time at a single observation, that is called as cross section. When you collect the data about one particular subject over a period of time, then it is called as longitudinal or time series analysis. So I shall be focusing on these two things. So if just for your information, you have a small chart coming up on your screen. Now, if you observe there, different groups are compared at the same time, that is cross section, whereas one single group is studied at different time frames, at different time gaps, that is called as longitudinal or time series analysis. Now we are moving on to our focal point of understanding. What do you mean by the term empirical modeling? Now, empirical modeling here refers to the process of creating mathematical or statistical relationship among the chosen variables that are based completely on your empirical observation. Empirical observation here is something that can be quantified in terms of numbers. So, modeling here refers to the process of creating a relationship that can be expressed mathematically or statistically in a way where you tend to establish a relationship among the variables. Now, what are the steps in empirical modeling? My dear friends, I request you to kindly make a note of this because this exact thing is what we will be doing in modeling. The first very important step that we do in empirical modeling is to formulate an estimable theoretical model. The first thing is we have identified a phenomenon. Once when we have identified a phenomenon, then we have certain assumptions as a researcher. We tend to develop a sort of a relationship without a empirical foundation, without a quantifiable basis. We tend to assume that there could be some sort of a relationship between one variable to another variable or one variable to a host of other variables. So this sort of a assumption, I will not call it as a presumption, this sort of an assumption is the beginning step in empirical modeling. Once when I tend to establish this theoretical model, the next thing is based on the variables that I have fitted a model, I will collect the data on all these models. Once when I collect the data, then I do something called as model estimation. What do you mean by the term model estimation? Now, we do not know anything about the data that we have collected. We do not know anything about the phenomenon that is there in our mind. So we need to establish some numerical values which will explain things to us. That is called as model estimation. After model estimation, the next very important aspect that we do is to verify, is this estimation genuine? Is it statistically adequate? Is it a correct model? If the answer is yes, then we implement it. If the answer is no, then we re-estimate. So finally, once when we say that the model is statistically adequate, we interpret the model and we apply the model in our research studies or in policy formulations. On the other hand, not in one try we will get statistically adequate empirical model. It is not that very easy. At the end of the session, you will know how difficult it is to pass the tests, statistical tests, in order to have a verifiable model. I'll share it with you all. Till then, just bear with me. All right. Now, let's focus on few basic concepts. Oops, is that your feedback? Why, Girish? yesterday, day before yesterday, that day before, we had so many explanations on several basic concepts. Dilip sir, Harikumar sir has explained several very important statistical concepts to us. Ishani ma'am has given volumes and volumes of understanding about the basic concepts. Then why are you trying to tell once again the basic concepts? And the answer is, my dear friends, kindly bear with me. I have made a disclaimer that I assume that the audience do not know anything about the basic concepts that we use in empirical modeling. So that is the answer. Secondly, there are certain things which were not covered yesterday, which were not covered day before yesterday, which are very much required for our model building. So an understanding about that will enhance your knowledge and understanding about the practical aspects of modeling. So with that intention, I thought, let me share a few very basic things very quickly. So it is purely for the sake of sensitizing you people and not in any way to educate. No. Hope you're happy with my answer for that. Maybe yes. All right. Let's quickly move on. The first very important concept that is a core to our understanding about empirical modeling is variance. Well, now, what do you mean by the term variance? Now, it is a squared deviation of the random variable from its expectation. That is, from we have unlearned everything concerning research. That's fine. Let's get back. So variance is an expectation of the squared deviation of a random variable. Girish, what do you mean by that? It only means that how near or how far various observation of the data is placed in your data point from the mean value. The answer is, near the observations, better will be the mean value. Better mean value will always help you for any statistical inferences. Stronger the mean, better is your understanding. Stronger the mean, better will be the quality of the data structure. Higher the quality of the data structure, better would be your inferences. That is what is the meaning of it. How do we do that? Very simple. We will deduct the value of a variable, X variable. I here means at ith observation from its respective mean value, and we divide it by n. We get a measure which will tell us, look how closely or how far all the observations are arranged from their mean value. Closer, the better. That also means lesser the value, better is your understanding. So that is the meaning of the term variance. Now we have another very important concept, once again, on which the entire concept of empirical modeling is based on, and that is covariance. Now, covariance signifies the direction of the linear relationship between two variables. Now, please understand that when the variance in one variable is very closely associated with the variance of another variable, then we say that both the variables are moving together as far as the variance is concerned. So we say covariance. Now this covariance, a statistical property among the chosen random variable, will help us a lot in understanding various statistical concepts and the behavior of these random variables, which help us in applying statistical techniques on them. Now, once again, here it is the direction of the linear relationship. What do you see here? We always use the term linear. Linear here means something which can be proportionately measured throughout the observation point. Something which the rate is fixed, something which can be explained on a straight line. When x increases, y increases. When x decreases, y decreases. That sort of a relationship between two or more variables is called as linear or linearity. So covariance is a linear technique. Please try to understand that, which is very important for us. So covariance is a measure of a relationship between two random variables that evaluates how much and to what extent the variables change together. What, Girish, you're showing a formula? Yes, I'm showing a formula which is very important for us. Kindly have a look at the formula. Once again, what we do is we take the variance of X, we take the variance of Y, and we multiply, we get covariance. All right. So as I told you, covariance tells us the direction of the linear relationship. Now, if both the variables, the variance of both the variables are moving in the same direction, then we say that there is a positive covariance. On the other hand, when variance of one variable is not going in the same direction of the variance of another variable, then we say it is a negative covariance. And when there is absolutely no relationship between the two variables, we either say that there could be a weak covariance or there is no covariance. Nevertheless, dear friends, covariance has got certain disadvantages. It does not measure the directional relationship between two variables. Girish, just now you said it measures the direction of linear association. My dear friends, I want you people to focus and follow me very carefully. I only said it measures the direction in which the variables move, but I never said that it measures the directional relationship between one variable to another variable. Now, when you say there is covariance, can you say that one variable is causing another variable? Can you say that it is because of the variation in X, Y is having its variance? So that is called as directional relationship, which cannot be understood in covariance. The next, it does not show the strength. We say that there is covariance, but if the question is to what extent, how much, can you tell the degree? And the answer is no, we cannot tell that. We cannot tell the strength of the relationship between two variables with covariance. The next and the most difficult aspect about covariance is that the unit of measurement is squared. Now, if you remember, that is why I showed you the formula. We take the squared deviations. When we take the square deviation, the units will also be squared. For example, if we take X and Y as kilometers, then the resulting answer will be kilometer squared. Is there anything called as kilometer squared? And the answer is no. Then how can you interpret? How can you analyze? How can you generalize? The answer is no, you cannot. Moreover, we can never say that the units are same for X and Y. One may be measured in liters and another one kilometers. Now, just imagine that particular number that you get. It is absolutely no way in knowing which unit it is. So that is a problem with covariance. That is why we have the next very important aspect, which was spoken a lot about by Ishani ma'am, and that is correlation. What do you mean by the term correlation? You all know, I know. Correlation is a statistical measure that expresses the extent to which two variables are linearly related. What do you, once again, dear friends, I said it is linearity that we are focusing on. We are not in any way speaking about the non-linear relationship, which is not covered by variance, covariance, and correlation at all. That means as a researcher, you must be very careful about choosing your variables, which one in turn decides the way in which you should give a statistical treatment to it. That is why correlation is applied basically only if you assume that there is a linear relationship, because it measures only the linearity between the two variables, and it also measures the extent to which the strength between the two variables. Now, why, Girish, you have given this formula? Just to sensitize you on how we calculate this. So very simple, we take the individual observation of X and we deduct it from the respective mean value. We take the individual observations of Y and we deduct it from the respective mean value, and we divide it by the variance of X and variance of Y. Have you come across this particular definition earlier? Yes, just 3 slides back, I showed you the same formula. It is the same formula. Furthermore, Girish, will we ever use this formula? Definitely yes. If not so, you are using the next formula, which is called as covariance of XY divided by standard deviation of X and standard deviation of Y. Please make a mental note of this particular formula, which helps us a lot about various other applications of model. All right. So once when we say the extent to which we can measure and tell about the strength of the relationship between two variables. That is what we call as degrees. To what extent? Just have a look at this. I know you know all these things. It is, as I told you, just to brush in our understanding. Now, correlation is a relative measure. It does not have an absolute value. So there is no problem of units to it. Whatever might be the way in which your variable is measured, kilometers, meters, square kilometers, whatever it could be, but correlation will not take that unit into consideration. It is a relative measure which tell you the degree of the relationship. So that degree can vary between -1 to +1, where 0 is neutral in it. So if you get 1, which is a theoretical correlation, then we say that there is perfect positive correlation, which can never be found unless your data is wrong. Usually your points will be from 0.9 to 0.7, 0.6 if your correlation is good. Or if there is a negative correlation, there is also a possibility. The same linearity may be inversely related between X and Y. All right. The more salary we get, the lesser happiness we have. That's just a joke. Now, there might be an inversely related X and Y. And that is called as perfect negative correlation or high degree of negative correlation. So we use these degrees of correlation, which will help us very clearly to know to what extent the relationship is quantifiable. All right. Why regression? Oh God. Now I think you're asking a question. There is a question in your mind. Girish, fine. We have variance, we have covariance, we have correlation. Don't you think it is sufficient for us to start our statistical analysis? Why is it that we need regression? Organizers, is the chat box enabled? Okay. I think the chat box is enabled. Swaminath sir is telling to know the impact. Okay, dear participants, I'm quite popular in one thing, let me tell you, and that is putting my audience to sleep. So in any of my FDP program, what I do is I'll always have a dialogue rather than a monologue. I don't believe in talking always to myself. Therefore, I want an active participation from all the participants in the form of giving their answers. Once again, do not get offended when I ask a question. It is purely to involve you all. And to screen is not working. No, it is working, Sumanji. Maybe you have an internet issue. All right. So dear audience, dear friends, do not mind me asking this question. What do you think? Why should we need regression? Yes, sir. Interactive. Yes, yes. Dr. Kushbu Kumar. Definitely, yes. All my FDP programs are glaringly interactive in nature. To estimate the unknown, oh, no. How does Carl Pearson correlation enables to take possible decisions? All right. No, that is not what I was expecting. Now I'm asking a question, a very simple question. And that is, Mr. Virendra sir, do not scratch the screen. I assume that it is because of the frustration of listening to Girish. Thank you, Virendra sir. Prediction. Examine the relationship between two or more variables of interest. Good. To know value of one variable with one. All right. Very nice. Now that is what, to know the impact of one variable with another. Yes, bullseye. To identify which variable have impact on the topic. Fantastic. Very, very nice. To understand the impact of variable on the other. To understand the impact. Fantastic. I appreciate your active participation, which has definitely made me to, in case of non-linearity, determine the strength between dependent and independent. Fine. That's fantastic. We need regression because of the limitations of correlation. Correlation always identifies the degree of linear association. That's it. But it will not help us in any way to forecast the future changes that may happen to the chosen variables. That is the most important drawback of correlation, because of which we use regression. The next one, the most important thing, as how you people have put it across, correlation does not capture causality, while regression is completely based on causality. Now the question is, what is causality? When the movement of one variable brings in a change in another variable, we call that phenomenon as causality. Cause here means it is not one variable causing another person. No. One variable cannot cause another variable. Rather, when one variable can influence the changes in the value of another variable, and that is what is called as causality. When I say X and Y are linearly related to the extent of 0.9, now that is the end of correlation. It will not tell me whether X is closely associated with Y or Y is closely associated with X. So yeah, it will not in any way tell us about the degree of the direction from where this particular relationship is causing. The next very important thing is whether you take correlation value from X to Y or from Y to X, you get the same correlation. When you use cross tab in your SPSS, you will know that we have a correlation matrix. Whether you read from X to Y or you read from Y to X, correlation is same. But that does not happen in case of a causality, because how and in what way X causes to Y will be completely different from what and in which way Y is causing A. It may so happen that it is only X, a variable, that would be bringing in a change in Y, and Y's change may not at all affect X. So that is where we make a differentiation in the variables as dependent variable and independent variable. All right. So it is because of all these things that we have another statistical technique which is called as regression, which can give you the answer in the most effective way on all the demerits of correlation. Now the question is, what is the regression? Girish, why are you asking so many questions to us? Yes, I have told you. Is there anybody who can just try to give a small meaning of the term regression? Or can I say that regression is antonym to correlation? Cause and effect due to inter and compulsive inducement of variables. Sayed sir, are you a science faculty? I appreciate your contribution. Now, why I asked this particular repetition, Sheikh ji? Is correlation same as regression? And the answer is no. Then what is the difference between correlation and regression? Then what is the meaning of the term regression? I always remember this and I share it in all my FDP presentations. Now I took this: correlation gives relationship, regression is free, regression is forecasting. Very good, very good. You people are all making my task much, much easier because all your answers are wrong. No. Okay. Listen to this, dear friends. On a lighter note, I took up the same discussion to one of my classes and I asked this question to my students. Okay, dear students, now that you know correlation, now what is the difference between correlation? I am hungry while watching video, it is correlation. You are hungry while watching video is correlation. Good. 1 minute. Then, okay, I'll get back to you on that. Let me just complete my sharing of this. So in one of my classes, I took this question. I said, dear guys, what is the difference between correlation and regression? And to my surprise, my favorite student from the last bench stood up. Sir, I know the answer. But it's very simple, sir. What? Correlation means coming together. Regression means falling apart. Is it so? Do you agree with this explanation, this answer of my student? Do you think that nice reply, Kadar sir? All right. Do you agree with this? There is truth in it, Sudhaji. Yes, in terms of 2 points. From Dr. R.S.P. Singh, no. Regression is statistical method used to determine the relationship between one dependent variable and other data. Sadiq Pasha ji, I'm so happy to say that you are wrong. Please don't get irritated. It is just to fully just to make the session lively. Now the concept is serious, fine, but why should we be serious? Life is serious, but why should we be serious? Cause and effect relations? No. That is why it is very important for us to have, in regression, we have an equation. Even in correlation, we have a equation. Okay. I'll not trouble you much. Let's move on to the next slide quickly. Let's try to understand how this entire concept of regression came into the picture. It so happened in the year 1889. Sir Francis Galton conducted an experiment by taking a very large set of samples. What he did was he collected the heights of a very large population of fathers and the heights of sons. When he tried to establish correlation between the heights of fathers and the heights of son, a very new sort of a phenomenon was observed by Sir Francis Galton. Now this gentleman, he is called as a polymath because he is not just a statistician, he is an inventor. He was knighted, a man with multi-talents. Now he identified a unique phenomenon, and that is, we always tend to believe that fathers who have good heights will always get sons also who are of the same heights. So taller fathers would generally get taller sons, and shorter fathers would get shorter sons. Girish, that is natural. No, dear friends, that was not natural by the experiment that was done by Francis Galton. He observed that once when the entire population, a very large population was observed, generally taller fathers used to get sons of a lesser height than theirs, and shorter fathers used to get sons bit higher than their age. Then he started pondering on this particular question, and then he identified a unique phenomenon, and that is that there is a change in the average value. Why? Because when we take a large population and when we study that population, that particular variable always tend to move towards its mean value. That is what is called as regression. If you want to study more about it, now I have given you this particular research paper of Sir Francis Galton, Family Likeness in Stature, Proceedings of Royal Society, which was published in the year 1886. In this, he identified this phenomenon. The heights of the children of unusually tall or unusually short parents tend to move towards the average height of the population. Further, a student as well as a friend of Galton, Carl Pearson, also conducted similar studies on correlation by taking the same population. And then even he supported the views of Francis Galton, and he said very slowly the heights of the sons are moving towards the respective mean value of the whole population. When you take the respective mean value of the whole population, then there would be a transgression of the values, individual values, towards a value called as mean value. And this is what is called as regress. So it was Francis Galton and Carl Pearson who coined this particular word called as regression, which means a phenomenon that is identified in a random variable, which always tries to fall back to its mean value. Dear friends, note this point. I said tries to come back to its mean value. This very simple. Once when the truth is known to us, we always say that it is simple. And that is what is the phenomenon. When you take a large number, you take a mean value, then you will find that all measurements are coming back to their respective mean value. Now, if this simple thing, my dear friends, if there are some stock investors in this particular group, you would know what I'm speaking about. There are a very large number of technical analysis tools that are used in stock trading and stock prediction that are completely based on this simple phenomenon called as regression. For example, you all know that we have two different types of technical analysis tools. One is indicators and another one is oscillators. In indicators, you have got moving averages. Moving averages means you will take the stock prices for 3 months and you establish a line, and as per the line you will start predicting what could be the share value tomorrow, day after, the day after, by knowing the difference between the mean value and today's price, because you know that today's price may come back. There is a larger probability of today's price that may come back to the mean value. So that is moving averages. There are several hundred types of moving averages, and one of the most popularly applied moving average technique is exponential moving average. 14-day EMA, 1 month EMA, 7 days EMA. There are several EMAs. All these exponential moving averages are completely based on this phenomenon. That is in terms of indicator. In terms of oscillator, you have got one of the fabulous tool which is called as Bollinger Bands. Maybe those who are trading would know that. The moment you apply that Bollinger Bands, you will come to know to what extent your share price has moved away from the mean. Then you can predict whether it will come back to the mean based on the behavior. Within what given interval that share price has in the previous days, previous months, has come back to the mean value and it has shot up or shot down. Now, this is called as Bollinger Bands or volatility oscillator, which is based on this concept of regression. And it is this phenomenon that we take in the terms of empirical modeling. All right. So this is a gentleman, Carl Pearson. Then what do you mean by the term regression analysis? Regression analysis is concerned with describing and evaluating the relationship between a given variable. Several answers were given to me, but the question was, what is regression? All your answers were given for regression analysis. Therefore, I was very happy in saying that you are all wrong. All right. So let's get back. So it is a regression analysis is describing the sort of a numerical relationship between one variable to another variable, as well as evaluating in terms of quantifiable numbers, the strength, the degree of that sort of a relationship between one or two variables or between a large number of variables. How? By verifying the movements of one variable, bringing in a change in the movement of another variable. What are the uses of regression analysis? As you have already given the answers, I will not take much of my time. It is estimate to determine the effect. Now, once when we start observing the phenomenon, when we are trying to estimate a model, I told you that is the first step. Then you would come to know that yes, this could be getting influenced by this. So this variable may be caused by another variable. So by yourself, you tend to make a differentiation, or with the help of review of literature, you tend to make a sort of a differentiation between what is dependent and what is independent. Or you have already chosen a research topic, you have identified your research variable. If that is the case, then you will identify what are the various other variables that are related to your variable, and you try to determine the effect. That is what you do in regression analysis. And the third, can you please differentiate between regression and regression analysis? Regression is a phenomenon. Based on that phenomenon, we have a sort of interpretation of the variables and their behavior, and that is called as regression analysis. That's all. Now, generally what happens is we may not know, we may not have had sufficient time, we may not have, it's not that it must be there, but it increases your ability to understand once when you know the core of a concept. That is what is my take on that. Always the answers will lie in the simplest form. That is what I have observed. So that is generally speaking, generally speaking, we do not focus more on this behavior of the variable, which is called as regression. So the meaning of regression is not falling apart like how my student said. It is actually slowly progressing towards the mean value. Now the same tendency will be observed by you all in my tomorrow's presentation, which will be more, because the entire concept of time series analysis is based on this moment. That is why I underlined the importance of it. The third most important aspect of regression analysis is to predict. Based on known, you will always try to predict the unknown. And how? That is what we do in regression analysis. Now let's quickly move on to this types of regression models. My dear friends, there are actually several other models that we are supposed to take it, but all those other models are one or the other way a sort of a minor manipulation of this core models, and that is why I finalized only on these. There are, other than whatever I have shown, like how Ishani ma'am said yesterday, a large number of other models too, but which can be broadly classified in one or the few aspects of it. The first very important type of regression model, the most commonly used regression model, the most easily interpretable model is linear regression model. But the only as the point about this linear regression model is that it is applicable only when the variables are linearly related to each other. Only when the coefficients are linearly related to each other. What do you mean by that, Girish? I'll explain it in my future slides. The next one is logistic regression. There is another minor variation of logistic regression, and that is probit, probabilistic model. So one is logit and another one is probit. Whether it is a logit or a probit, we use this regression when the dependent variable is a categorical variable and when the outcome is categorical in nature. Yes, no, 1 or 2, true or false, probability of 1 or 0. Whenever we use the dependent variable as such, then we cannot use linear regression. We have to use logistic regression, which actually transforms the categorical variables into linear form, and then we'll give your analysis to it. Now, when there is a non-linear association, Girish, what do you mean by non-linear? Whenever the moment of one variable does not cause the same rate of change in another variable, where at any point the impact changes, or when the impact does not die down quickly, which we call as clustering, then it is called as non-linear relationship. When X increases by 5%, we say Y increases by 5%. Then that is linearity. When X increases by 5%, Y increases by 25% today, tomorrow 40%, day after tomorrow 0. That means when you try to plot the same in a graph, you may not get a straight line. It's not you will never get a straight line. You will get a curvy linear thing. You get a polynomial line, zigzag behavior, and that is what is called as non-linear. So whenever the variables exhibit non-linear relationship, or when the coefficients have got a non-linearity in them, then we cannot use linear regression. Polynomial can be used only in longitudinal study, Dr. Kushbu. Polynomial regression, no. It's not always in longitudinal, madam. Polynomial regression can definitely be used when there is a non-linear relationship. Generally what happens, this non-linearity is observed over a period of time, madam. That is why it is inferred that in longitudinal studies we use polynomial regression. All right. The next very important thing is stepwise regression. Now, if you have a host of explanatory variables, apart from regression model, what other types of models in econometrics? That's what I'm exactly telling. Now, other than linear regression model, we also have another very important model called as stepwise regression model. That is, when you're not decidedly clear about the number of explanatory variables that you want to include in the model, you do a lot of iterations in the model. Iterations here mean you include 5, you establish correlation, you establish regression, you check the result, exclude 1, then you have 4, then exclude another, you have 3, then exclude another, you have 2. At every iteration, you check certain key important values. You will see whether the result is improved or not. Based on that, you decide. So this sort of a relationship is called as stepwise regression. Now, ridge regression and lasso regression is something which will be a problem in the scaling. When you take numbers, when you take the variables which are expressed in sufficiently large quantities, the coefficients will also become quite large. When the coefficients are large, then it is very difficult to interpret models other than various types of regression. Ma'am, whenever we speak about a model, it is always regression. Please allow me to move on to further slides. Maybe you will get a clarity about it. I'll come to that question, Khadar sir. Now, cyclical and secular changes can be observed only in longitudinal studies, sir, because at one point of time, we cannot observe cyclical changes on the given variable. So all those problems will come when the data is time series in nature. So let's quickly move on to ridge and lasso regression. Now, as I was telling you, when you take sufficiently large coefficients, when the coefficients that you derive are sufficiently large in nature, then you need to regularize this by using a concept called as L1 regularization and L2 regularization. What they do is they introduce penalty. For example, in ridge regression, L2 will be used, which introduces a penalty. A penalty term will be introduced, which will reduce the value of the coefficient. So that is what is called as regularization technique. On the other hand, in case of lasso, least absolute shrinkage and selection operator. Least absolute shrinkage and selection operator. What it does, it will deliberately try to bring in zero to the model. It will try to reduce the value of the coefficients to zero by adding a penalty term. Now, when that happens, it will be very easy for you to get rid of a particular variable, an explanatory variable that you have chosen for the study. Now, when you combine ridge regression and lasso regression, and when you establish a regression analysis, it will help you very much to make a choice of different explanatory variables, and that method is called as elastic net regression. All right. Now, in all social sciences, in majority of the circumstances, we always tend to use linear regression, and seldom we use non-linear regression. And especially we use non-linear regression in financial studies in case of studying the volatility of the variables. So because volatility as such, in my tomorrow's presentation, I'll cover that, is completely something which is based on non-linearity. Other than that, in majority of the cases, generally speaking, on the whole, we use linear regression. Why? Basically, majority of the things that we take in social sciences research are linearly related to each other. That is why. Now we are moving to the core of my presentation, which is called as theoretical background of regression. Once again, dear friends, based on my limited exposure towards this empirical modeling, many a time, stretchable acceptance, is there any benchmark, sir? I'm not clear with your question, Kadar sir. Kindly repost your question with an additional explanation. What do you mean by stretchable acceptance? I do not know about that. Let's get back to this. So in my limited exposure, many a time, even at IITs, the researchers generally do not bother much about the basic understanding of regression, which has troubled me a lot. And that is why I thought it is very important for us to have a theoretical understanding of regression, because there is a theory that goes behind the regression. And that is, my dear friends, data generating process. Data generating process here refers to the phenomenon that you want to study, that you are trying to study, that you are trying to model. Data generating process can be a phenomenon, or it can be a problem, or it can be a host of things that you are trying to model. And you're so very confused that you do not know anything, because none of us can understand anything about the changes that are happening, and that is what is called as data generating process. What do you mean by this, Girish? That means any problem that you take will have a phenomenon in it, will have a totality in it. Any problem will have a totality in it. Any phenomenon will have a totality in it. Any research is just to identify a small particle of it. And this is already there in the nature, which is called as data generating process. So what do? You tend to gather data from that. What do you mean by the term data? Information from the data generating process that you collect in the form of numerically verifiable form, then that is called as data. A data is the information that you collect in a quantifiable way. All right. Intervening variable. Is that your question, sir? I don't know. 1 minute. I'll come to that later. We are still at a very basic stage here. Intervening variable. I'll come to that. Allow me to move on with my slides. So data generating process is nothing but the phenomenon that you want to observe. You cannot observe the whole phenomenon. Therefore, you tend to collect some sort of a probability based collection, because you cannot collect data from everywhere. So whatever is possible from any source that is possible, you tend to obtain the data or the information in quantifiable form from that data generating process, which then leads you to develop a model. Now that is the core of our discussion today. And what do you mean by the term model? Model is the mathematical expression of the nature of a relationship between or among chosen variables. Now, you have certain variables that you have identified for your study. Now, you need to absolutely give a relationship to that variable based on what you have observed, based on your understanding about the problem, based on the understanding of the phenomenon, and that is what is called as a model. How do we do that? Generally, we say that our research question, which is a dependent variable, may be, because we don't know anything, may be a function of one or few things that are happening around us. That one or few things that are happening around us are called as independent variables. How do you select it? Based on your review, based on your understanding, or based on your guts. Many a time, my dear friends, we also need to use guts, and I have done that in my research. Is there any difference between term empirical model and econometric model? No, there is absolutely no. But there is. Whoever asked that question, please bear with me for some more time and allow me to move on with my slides. All your questions may be answered by me. I don't know, because I have certain things further in my slides. So bear with me for some time. I will take up that question. So I was telling you all, my dear friends, that you have observed certain things. You have certain gut feeling. Why gut feeling, Girish? Because many a time you may not have review of literature at all. No, don't laugh at me. There are many things on which there is no review of literature. There are many things on that the research has not at all been done. It's still happening. My research paper got accepted by NISM SEBI only because I have identified a problem for which there was no review of literature at all. So it's only because of that, only because of fitting a very simple empirical model. I did not fit any complicated model as such. As I told you, I believe in simplicity because I was told by my professors at IIT that the more simple you are, the better will be your result, because entire econometrics is based on a philosophy which is called as parsimonious. Your model must always be parsimonious. Parsimonious means as simple as possible with as less number of explanatory variables as possible. You need to take your research into. So I used a very simple approach, but I identified a problem for which there was no review at all. Actually, two such things. What are your area of research? Sudhaji, the paper that I wrote, which was selected by NISM, was pre-market price behavior and overnight news impact. So this overnight news impact was my observation. My observation in the sense there was no research on it. That's all. It's not that only I identified. No, it is a phenomenon that is already there. My basic question was this. Today evening, your stock market will close and tomorrow morning it will reopen. Will the share price be the same is my question. The answer is no. But in accountancy, we have studied that closing value of an item will be same as the opening value of the item. Buy balance carried down will be same as to balance brought down tomorrow. But that cannot happen in financial market, especially in stock prices. Why? Why? Because of things that happen overnight. Only you sleep, your money won't sleep. Because money never sleeps, information never sleeps, things will never ever be quiet, things are dynamic. So when your markets closed, common sense, other markets will be open. When other markets are open, things are happening there. When things, Dolly G, what is that? I don't understand. Your arrow mark, I don't understand that. What is that? Dolly G, please take out this arrow mark. Unintentionally, maybe you have done. Yeah, thanks for that. How much ever you people irritate me, I will stop only when I want to stop. So allow me to complete whatever I want to say. So for this particular thing, the assumption was as simple as this. American markets open when our markets close. So something may have happened in American markets. And overnight, the things would have happened there. And overnight, the news may have come to India. Early morning, that news would have affected Singapore market. And by 9:15, we will be ready with what we need to do for that particular day. Our strategies would be ready. Our bettings would be done. Our books would be filled with orders, buying and selling order. Based on what? Based on our understanding. Now, I took up this particular problem and I applied a very simple ordinary least square equation. And I got the answer. See, because of this, these are the things that are happening. There is an information flow that is happening, and it is this information flow that is causing the changes in Indian market. So I was able to empirically evaluate that and present it. Now, this paper surprisingly was selected. I'll tell you, there's nothing great in that. It was just a novelty, a new thought. And I openly said, I don't have a review of literature. Fine. So people at SEBI said, it's fine. When you are convinced, when you are able to prove, and when you have evidences with you, Girish, that is what is sufficient. So I got the honor of presenting the paper along with IIM and IIT professors and researchers. I mean, that's a great thing. In the sense, I got that opportunity because of a gut feeling. That's what I'm trying to tell you all. When you identify a model, when you are trying to develop a model, many a time you may not have a review of literature, but still you can take things. Nobody is telling you can't. Nobody can do that. Research is, that's why it's such a beautiful thing, because it always asks one simple question. Can you empirically evaluate it? And the answer is, if it is yes, you have a model. If it is no, you don't have a model. Now, these models, I'm coming back to the question that was asked. What is the difference? Are all empirical models or econometric models? Somebody asked that question. Now I am coming to that, dear friends. All models are broadly classified into two categories. All models, any model for that matter, is classified into two broad categories. One is deterministic model and another one, okay. Deterministic model here refers to a model where the behavior or the changes in a dependent variable of your choice will be explained by alpha, which is the average value of y, and the rate of change that happens in y whenever there is a change in x, which is called as beta. So when we say, Girish, this is what it is. This is my dependent variable, which can be completely be explained by its average value and the independent variable that I have chosen. Then it is a deterministic model. On the other hand, you have got something called as stochastic or random models. Madam, it is these stochastic or random models are called as econometric models. Why? Look at the answer. Because there is an introduction of a new term here, my dear friends, which is a core of our discussion, and that is called as disturbance, which has come right to disturb you people there. Now the same dependent variable, now it is telling me that Girish, the dependent variable y can be explained by its average value plus the rate of change in that value by the changes that are happening in the x value. Other than that, the changes in y can also be explained by another component called as u, and u is a term of disturbance. Why is it that we use the term disturbance? Answer is very simple, because it is this term that disturbs the value of y. Whatever value that y has obtained in the presence of x will be greatly influenced the moment you include the term u. And it is this simple thing called as u, that has made a difference between deterministic model and stochastic model. Where do we apply deterministic model? Because of its capacity of completely explaining the dependent variable, it is applied only in scientific explanation. It is only used in scientific experiments, because all these experiments are controlled in nature. If I use 2 atoms of hydrogen and 1 atom of oxygen, definitely I'll get water. I'll not get anything else. Is there a possibility of I getting anything else? And the answer is no. How many ever times we apply E equals mc squared, I'll have to get the same output. So that is what is called as deterministic model. Nothing else. You are daringly telling Girish, nothing else will ever influence y, because it is completely explored, it is completely explained, it is completely understood by the changes in x. Can we have such a kind of a deterministic tendency in social sciences? Very simple question I would like to ask you. You have taken 2 doses of vaccination, Covaxin or Covishield, Sputnik, whatever. Can you say, Girish, 100% I will not be affected by corona? If that is the case, then was there, yes, everyone are reacting now. Is there a possibility that you will never be affected by that? No. Now, if Pradhan Mantri Modi ji, if he vaccinates all to all Indians, can we daringly say that we have completely eradicated corona? We are 100 times better than America. Can you say that? The answer is no. Why? That is because there is no certainty in it. Why there is no certainty in it? Because of the random changes that happens in the world will never be under our control, that cannot be seen by us. Yesterday we had alpha virus, today we have delta virus, tomorrow we may have gamma virus, we may have anything we don't know. We are always ignorant in the sense that we do not know what happens tomorrow, though there is always, yes, I said this, dynamism. Why dynamism has come? Because of a concept called as random. What do you mean by the term random? By chance. There is a probability for everything. There is a probability for each and every change that is happening. Can I say that tomorrow it will be a case where there will be a complete rainfall in Bangalore? And the answer is no. But can I predict it? Can I predict? And the answer is yes. Then what do you mean by the term prediction? When I associate my forecast along with a possible probability, then it is called as prediction. So here, whenever we use a term which includes all those random changes that are happening around us, along with including the explanatory variables, then we are also giving chance for that probability to come into our model. And that is what is called as a stochastic, random, or in other terms, it is called as econometric model. Mathematical model will not have a chance of probability in it, but all econometric models will have an element of statistical probability in it. Why is it that we use this term? Further, we use this term because we cannot observe all the attributes of y. We do not know. We may have observed by review of literature or by constant observation, we may have observed 1 or 2 changes that may happen in y, but we cannot observe the whole changes that are happening in y. Y means dependent variables. So we say that this is what I have observed, other things I don't know. When you say I don't know, that is where u comes to disturb you. the independent variables chosen may not explain the way. You say that this is my independent variable, Girish, but I'll say that what is the relationship, man? That your independent variable cannot influence a dependent variable. Why are you taking it? May or may not be. We don't know. That is why we do, okay, if this variable cannot explain the changes in Y, then let U explain the changes in Y. U here refers to a disturbance term. There are bound to be random outside influences. Things keep on changing. There can always be a dynamic interaction, iteration in the values. There might be difference in the time of you collecting the data, observing the data, and validating the data, extraneous changes. Therefore, we say, see, when we don't know, the most beautiful thing human beings do is when we don't know anything, we just assume. None of us have seen ghost, but we say, oh, ghost will always be wearing white saree. Who said that? In some movies it is said, but it is a general assumption. In the night, if we see white, oh. So that is the disturbance term. We don't know. When we don't know something, we assume. And these assumptions are called as U. Finally, we can predict anything, but we cannot predict. No, it's not always economic laws, sir. Any law for that matter, any changes that are happening cannot completely say about the things that are happening. And that is why we say that it is phenomenon. A phenomenon cannot be completely understood. All right. So you cannot predict. You cannot analyze. Nothing can be done. Therefore, you always have this randomness here. And in order to model, at the end of the day, my dear friends, we human beings will not easily accept defeat. We are the people who have come out with vaccination for corona. Imagine. So what we say, okay, we have not seen the disturbance, fine. We do not know when it comes and affects us, fine. What can we do? If you can't see, you just try to model it. You include it. You include it in the term, develop some sort of techniques by which you will also tame that particular thing that you have not seen. Simple. And that is what will be done in all econometric models. We tend to model that. Once again, in regression models, now earlier it was methods, here it is models. There are two broad categories to which we group the regression models. One is linear regression model and another one is non-linear regression model. Whenever we feel that the coefficients have a linearity, then we apply linear regression. And when we say that there is a sort of a non-linear behavior that can be observed between an independent and dependent variable where the coefficients may exhibit the alpha and beta. These are the two coefficients, parameters, which may tend to have that sort of a non-linearity in them. Then we do not apply linear, we apply non-linear regression models. The fundamental concept today is linear regression model. Now in linear regression model, we have this first thing which is very important for us, and that is population regression function. What do you mean by population regression function? As I told you, this is the beginning step. You please recall my earlier slide. I told you we tend to develop an estimatable model. Now this is what is called as population regression function. Population regression function is what are things according to you. How have you understood that phenomenon? Some others may have understood it in different way, but how have you understood it? So that depends on your review. You say that, look, out of this review of literature, I found that these are the variables that are influencing my dependent variable. Therefore, I have developed a relationship. Now, this PRF is purely a theory that you have built at the beginning of your research journey. And that is called as population regression function. You assume, you tend to believe, you understand, or you hypothesize that this could be the function which you believe. Dear friends, it is you who believe that it might be a true relationship. That is what is called as population regression function, which is the beginning step of any regression modeling. How? You say that, sir, my dependent variable is always influenced by its own value, okay, plus by one or few chosen variables. If I take only one variable, it is called as univariate regression model. If I take more number of variables, then it is called as multivariate model. So it all depends on, once again, my population regression function that I am developing at the beginning of the research. And invariably, I have this term UI, which has to be included, because I do not know that the entire Y can be explained by X. No, I don't. So that is what is called as population regression function. Now we come to the central focus of our discussion, and that is estimating the coefficients of a linear regression. What do you mean by estimating the coefficient? Now, Y is something that you have identified as a dependent variable. X you have identified as an independent variable. How do you fix a value for the alpha, and how do you fix a value for beta? That is called as estimating the coefficients of a linear regression. For estimating the coefficients of a linear regression, we have three most commonly found methods, and that one single method is ordinary least square method, OLS method. Why it is called as ordinary least square method? Because it was the thing that was introduced in the beginning. It was a thing which is most commonly found in all research studies. It is something which is very simple to apply and to interpret. That is why we say ordinary least square method, where we do not do any additional treatment and we take the items as they are and we run a regression. That is why we call it as ordinary least square method of regression. So please understand, in linear regression, one method of estimating alpha and beta is OLS. Another method is maximum likelihood estimation. And the third one is method of moments. In all these three, we generally tend to use OLS, which is easy to apply. That's all. How do you use least square estimation of regression coefficient? Now, as the very name suggests, we use a concept of partial derivative function of the variable, which is called as least square estimation. How do we do that? For example, we take a sample of paired observation. Paired observation is we take the sample observation of few Y values and a few X values. We collect it. We collect the data from your dependent variable. You collect the data from your independent variable. After collecting that, you want to run this particular equation. Now, alpha or beta naught is same. Do not get confused. Same, absolutely same. How do we do that? So we estimate beta naught and beta 1 by minimizing the sum of squares of the difference between the observation and the line in the scatter diagram. Do not get confused. I told you, you have obtained the data. Fine. When you have obtained the data, that is called as actual data points. Based on the actual data points, you fit a particular line on the basis of principle of minima and maxima, which is called as minimizing the sum of square of the differences between what you have observed and the line in the scatter diagram. All right, that should be always minimum. That will be always minimum. It is not that you people will do anything. It is the principle of least square. It is the partial derivative function that is applied will do that. Nevertheless, for your theoretical understanding, I am just showing you how they are done. First, this alpha value or beta naught value will be calculated by taking the average value of your dependent variable and the rate of change of the average value of the X variable. So this is beta naught. How beta 1 is calculated? Beta 1 is calculated by taking SXY divided by SXX. Now please pay attention. How do we calculate SXY? We calculate SXY by taking the deviation of all X observation from its mean value, all Y observations from the mean value, and dividing it by something called as variation. Have you seen this particular formula earlier? Yes, sir. It is nothing but covariance formula. That is why our understanding of these things are very much required. So it is the same formula that we use here, beta, rate of change, slope coefficient. And that is nothing but partial correlation of Y value when it is taken into consideration with the variation of X. How much variance can happen in y by the given variance of x. So that is called as partial derivative function. That's all. Do we need to do that? Absolutely no, no, no. Don't worry. You are not required to do anything. It is your software which will do wonderful things for you. Theoretical understanding is required. Now, how do you interpret? You all know that it's, as I told you, this is that partial derivative function. Beta 1 is nothing but the rate of change in the average value of y. Please understand, it is not that we tell anything in a decided way. Govardhan Ratla raised the hand. Can you please put it in the form of chat, please? Okay. So beta 1 is a rate of change in the average value of y whenever there is a unit change in x. What do you mean by unit change in x? It depends on the unit of the measurement that you have taken. If you have taken kgs as your unit of measurement, and if you have collected the data as kgs, then for every 1 kg increase or decrease of the x variable, what is the rate of change that may happen in the average value of y is what is called as beta 1, which is also called as slope. When what is beta naught? Sir, I applied regression and correlation in my MPhil manually. Now you are reminding informative session. But please understand this. Now we are actually coming to the climax. Not the end of my presentation. Don't be happy. No, no, no. I'll not be leaving you all so early. Bear with me. Because the climax of the story is the case that I have devised for you people, where, my dear friends, whatever I have told you, right from 1 hour, 15 minutes, will be shown by me step by step. Yes, that is my promise to you people. So what is beta naught? Beta naught is average value of y. That is when there is no influence of x on y, what is the value of y? That's all. Average value of y when there is no influence of x. So we take that into consideration, and we also take beta 1 into consideration, and then we try to analyze. Now, why and on what basis this principle of maxima and minima will be done? And that is based on the observations that you have done. The principle of least squares will run or will plot or will fix a line directly on the mean values of all the given x values. So invariably, this population regression line is nothing but the explanation, the expectation of y, that is the mean value of y for a given value of x. Now that is where is the difference between population regression line and alpha. Alpha is when y is 0. But what about beta? Beta is the slope. What is that slope made up of? The slope is made up of the average value of y for every given value of x. That is why I have shown you here ith observation of x. For every ith observation, see here, please look here. For every ith observation of x, what is the observation of y? What is the value fitted by the line to y? That is important. And that line exactly goes through the mean values of all the x. That is why we say expectation of y given the average value of x. Now, population regression curve is simply the locus of conditional means of the dependent variable for the fixed values of the explanatory variable. Girish, why are you bothering us? Why are you boring us? Hold on. I am coming to that. Just 1 minute. What are residuals? Now you will appreciate why Girish spent some time on population regression line. What are residuals? Residuals are nothing but what you have identified and what the population regression line has identified. Is it the same? And the answer is no. How could it be? Your population regression line will focus on minimizing the sum of squares, and sum of squares can be minimized only when y passes through all the mean values of x. So your population regression line, your software will be focusing on bringing down the sum of squares. It will not focus what is the actual value. Now that is where the problem of residuals come. The problem of disturbance comes. So disturbance is nothing but the difference of the actual observed value of the data and the fitted value. Look here, please. This is the population regression line. Sharda Patil raised hand. Please put it in the chat box. All right. Now, please focus on this particular population regression line. You could see that your population regression line is fitted on some imaginary values. But to be very frank, that is not the actual value. Imaginary value is totally different from the actual value. Now, this is your actual observation. Y is having one particular value, that is your observation. But your population regression function is telling you that, Girish, this is what is the value. Now, if you carefully observe this, we have put a hat on Y. That is called as Y hat. Y hat is the fitted value. Yt or Yi is the actual value. The difference between the actual value minus fitted value is what is called as residuals. See, Ei is the ith residual, is nothing but the function of the difference between the actual observation at ith point Yi minus the Y hat. That's all for every ith observation, 1, 2, 3, 4, 5. Therefore, you can also say that the residual is nothing but the difference between the actual value of Y minus what has been predicted. Who has predicted? The population regression line has predicted. On what basis? On the basis of mean values of X. All right. So in the most simple form, this is what is the meaning of the term residuals. Why it is important, Girish? I'll come to that later. Now that the thing here is, you have developed a model. You have given a functional form of the model. Fine. Y is your dependent variable. X is your independent variable. So you have decided, yeah, this is what it is. Now the question is, can you collect the data from your population regression function? Can you collect the data from the data generating process? And the answer is absolutely impossible. Then what you do? Then you collect the data from the sample. Same. Whatever you do in the questionnaire method, the same thing is done even here. The sample regression function is the relationship that has been estimated between the chosen variables by using the sample observation. Why sample observation, Girish? You cannot observe the population. Even though you can observe the population, you cannot collect the data from the population. Therefore, instead of collecting it from the entire population, you choose a possible scale and then you collect it from them. And that is what is called as sample population. Now, sample population also has got a function. Please pay attention to this. And that is called as sample regression function. Y hat, here we are giving a hat to it only to differentiate between PRF and SRF. That is in the general textbooks. Y hat is a function of alpha hat plus beta hat plus UI hat. So how we do that? We collect it from the sample and not from the population. All right. We collect the data of what? The data of Y and the data of X, but that is sample X and sample Y. And then we fit a regression and we run a regression on what? On the basis of least square estimation. How this least square is done? Once again, see, this SRF line is nothing but sample regression line. Based on X values, it has run a line, but you have got at every observation, there is an error in the observation. Ishani ma'am was telling about the errors in her session, and this is the actual meaning of the term errors. What do you mean by the term error? Error is nothing but residual. What is the meaning of residual, Girish? The difference between actual value and the value that is fitted by your model. Intuitively, if you observe, lesser the gap, better it is. Simple thing. So your Y hat at every point of observation will be equal to beta 1 hat plus beta 2 hat Xi. So that is the criterion. Now, what is the relationship between the population regression function and the sample regression function that you have taken? Very, very close observation is there, very close association is there between the sample regression function and the population regression function. Please pay attention to this. It's a request rather. This sample regression line will take into account the difference between your sample obtained observation and this fitted line. So that is UI hat. But theoretically speaking, that may or may not be the actual population. So you have this particular population line, which is as such. What you need to do is to compare your sample regression line with the population regression line, and the lesser it is, then SRF is having good predictive powers of the PRF. It's as simple as this. Now, whenever we speak about SRF and PRF, regarding you, we make certain assumption. As I told you, when we do not know something, when we have not seen something, we make certain assumptions. Oh, gods are like this. Gods have this particular type of body. They have these jewels. They have these weapons. They have these animals along with them, etc., etc. When we have not seen something, we make certain assumptions. So in order to check the sample regression function and population regression function, there is a requirement for us to have a set of assumptions for the disturbance term U. What are these assumptions? The first very important assumption, remember, dear friends, it is the assumption which we always make, and we always try to validate these assumptions. So it has been assumed that the expectation of UT, that is the mean value of the error terms, if it is arranged, then it is always 0. Okay, if the mean value is 0, that means it is normally distributed. Why, Girish? Because that is a property of normal distribution. Normal distribution corresponds to n. You remember 0, 1. What is 0? Mean. What is 1? Variance. Right? Now, the second important assumption is the variance of UT is constant. See, this is sigma square, which means it's constant over a period of time, or constant for all the observations. If you say over a period of time, then this is UT. If you say it is constant for all the terms, then it is UI. So the variance of errors is always constant. Constant. Another term given to it, and that is homoscedasticity. Make a note of that. Now the covariance between UI and UJ. What is UI and UJ, Girish? Ith observation and jth observation. So that means at any two subsequent periods, or at two subsequent observations, or at two subsequent errors, there must not be absolutely any relationship at all. So that is what we say, the covariance should be completely 0. This is also called as serial correlation. Right? Further, there must not be any covariance between the residuals and the independent variable. We always say that the relationship is orthogonal in nature. So there must not be any such relationship between the independent variable and the residue. Why is it so? When you use an independent term, that means you have taken out that independent term from the residual, because independent is already explained. What is error? Something that is not yet explained. Therefore, there must not be any relationship between the error term and the independent variable. Finally, we always assume that UT always follows normal distribution, where the mean value of it is 0 and the variance is equals to sigma square. That means constant. That means 1. So all errors are normally distributed. That is the assumption that we make. All right. Now I used two very important terms, homoscedasticity and heteroscedasticity. No, don't get irritated by me. What is this, Girish? You are using such words. The answer is very simple. We just use such a complicated word, homoscedasticity, heteroscedasticity. Skedasticity means variance. When the variance is same across all the observations, homo. When variance is not same across all observations or at all the periods, hetero. Look at this particular diagram. You will have a good understanding about this. It is very important for us. See, when at every observation, if the variance is same for Y or for U, then we say that it is homoskedastic. On the other hand, if at every observation when the variance changes, we say that it is heteroskedastic. What is good, Girish? Homoskedasticity is always good. Heteroskedasticity is your enemy. Shanmugam sir, my sincere request to you is, please bear with me for another 15, 20, 25 minutes, because it is there that we will be seeing the climax. Picture abhi baki hai. I have not at all brought that particular case that I have cooked specifically for you people. Hold on. Hold on for some time. Why? Because whatever you have learned, whatever you have understood will be seen by you practically. That is why. Now I think you are clear with this homoskedasticity and heteroskedasticity. I'll take that Smiley as your representative. Okay. But still, there might be an element of doubt in your mind. Girish, what is SRF? What is PRF? Is it really possible for us to do all these things in the research? Don't you think you're a bit too much? No. When we do empirical modeling, that is exactly the method that we follow. And that is why I have developed a particular case. Now, there are two disclaimers that I have to give, and that is this entire case is only for educational purposes. Point number one. Point number two, this entire case is completely false because the values have been created by me, which we call as simulation. The entire data here that I'm using for this case is a simulated one. Why, Girish? Why are you using simulated one? In order to get the desired effect, I have used the simulated model. What is the desired effect, Girish? I'll show it to you. So let's take up a case. The case here is recently Karnataka government under Department of Higher Education. Now this is real. This phenomenon is real. As I told you, everything starts with a phenomenon. So phenomenon is real. Karnataka government under Department of Higher Education, which is our department, which comes under Ministry of Higher Education, has come out with a beautiful, innovative teaching and learning pedagogy, which is called as Karnataka LMS, Learning Management System, where lakhs and lakhs of government college students would be given open access to an advanced learning modules in which they will be exposed to video tutorials along with PPTs, along with study notes, along with quizzes that they can take at their own pace, which will tell them, this interactive module, tell them to what extent they are prepared. So this unique experiment or a flagship program has been started by our department, and it is already being applied. Girish has got a doubt now. Girish, as you all know, is a researcher. Now I'm thinking, is this Karnataka LMS really helping students? Point number one, because the concept is novel, the methodology is novel, it is using cutting edge technology inside. Is it really reaching the students and is it really helping the students is what is Girish's doubt. Now see, there is a phenomenon. What is that phenomenon? LMS is a phenomenon. Aided learning methodology is a phenomenon. I am observing the phenomenon. When I observe the phenomenon, I get a research question. And that research question is this particular LMS helping students or not? So that is where you have to identify a research problem. Curiosity. All right. So I started my research. Girish is something like, he'll never be quiet. He started with his research, impact of Karnataka LMS on students' exam performance. How do you gauge and how do you assess a learning module? Very simple. By looking at the final output of this tool. What is the final output? Any learning tool's final output is the exam performance of the students. If at all, if the pedagogy is good obviously their exam percentage should increase. So I wanted to study the effect of Karnataka LMS on students' exam performance. All right. So let's assume this particular case. Now I have developed a model. Now this is a theoretical model. I say that, okay, y equals alpha plus beta x plus ui. So what is y? The exam performance of the students. Why? Because that is dependent on various things. What is alpha? Intercept coefficient. What is beta? Slope coefficient. What is xi? It is an independent variable which will not get affected by anything, but which will affect other things. This LMS will definitely affect in the sense it will positively impact on students' performance. Therefore, it is independent variable. But how am I taking this independent variable? Remember, it is empirical study. I need to convert the data into observable numbers. So I have taken a variable by name KLMS login hours. So I used a technique by which I could get for how many hours students would log in and stay in that particular module. Obviously, if they log in more, if they stay in the module, they learn more. If they learn more, their exam performance will improve. How did you guess this, Girish? Yes, I have made a hypothesis. That is what it is. Estimatable model. Formulation. I have formulated a model. All right. Now the point is, how can I go about collecting the data? Now, collecting the data is from all government colleges in Karnataka is almost impossible task. So what I did, I said, okay, let me go to a representative college. So I chose government RC college. I approached my guru, Professor Azad sir, and I said, sir, I want to do a research on this, and sir permitted, and of course with the permission of principal. Then I said, Azad sir, I'll take 100 students on random. Allow me to collect some questions from them. And they said, okay, fine. So I developed a questionnaire. I went to them and I collected the data. What is their exam performance? That is marks obtained in the exam. Okay. For how many hours they have used LMS. And then I also asked various other questions and I obtained the data from 100 students. All right. Once again, this is purely a simulation. I've never done that. It's just a simulation. Now, after collecting the sample data, what did I do? I coded it into my system. I have used eView software. You can use any software for that matter. You feed it and you run a regression. The moment I ran a regression, I got this. The average value of y, that is alpha, is 28.26. And KLMS login hours, that is the beta, is 10.06. What do you mean by this? What do you mean by this? Just recollect your sample regression function. Yi will be equal to beta naught plus beta 1 plus ei. So that means your exam performance dependent variable is 28.6. That means even without LMS, without anything, students will get an average of 28 marks. Fair enough. They may have studied, they may have some knowledge, they have done that. But if you introduce LMS, what is the impact? This LMS hours is telling me 10.06. What do you mean by that? 10.06 is the rate of change that happens in the exam performance whenever 1 hour is spent by the students on LMS. Well, what do you mean by that? That means if I log in and if I study for 1 hour in LMS, that will help me in getting 10 marks. On what grounds you're telling, Girish? Yeah, please look at the plus sign. What do you mean by plus? Plus means it's in the positive direction. Simple. Plus 10 means you will get a fundamental 28 marks. After spending 1 hour, change in the marks. Yes, sir. Yes, sir. Very good, Rohit Kumarji. That's what I'm trying to say. So you will get 10 marks increase whenever you study for 1 hour, subject to certain conditions, obviously. Because we have maximum marks, you have maximum number of hours that you can study. Qualitative aspect, no sir, we will not take qualitative aspect at all. It is empirical research and modeling is always quantitative in nature. We completely ignore qualitative aspects at all. All right. So now I have developed a model. Fine. What is next? Can I go to government? Can I submit it to my department? Is a wonderful. See, it's a fantastic thing. So we have developed a beautiful model which is able to predict it. So we have to definitely improvise on that. We can introduce it. Can I do that? No. Why? No, Kadar sir, no, you cannot do that. Why? Because whatever I collected is only from 100 students of RC college. Now, how can I say that this particular model is true to all the government colleges? On what grounds can I tell that? Is beta naught that I got in my previous model will be a true representative of the population beta naught? First question. Second question. Is the slope that I got, beta 1, is it the true representative of the whole population of all the government colleges in Karnataka? Can this particular model that I have fitted completely explain me the entire Karnataka LMS effect truly on the population? Can I decidedly tell that? And the answer is yes. How? On the basis of the next most fascinating aspect of statistics, and that is inferential statistical tools. So based on certain techniques, we can generalize our findings. We tend to, not tend to, we may decidedly announce that based on my sample data, this is what it is for the whole population. How do I do that? One of the most popular inferential statistical tools that we use is t-test. Girish, why t-test? Very simple, because t-test will fulfill all my requirements. One is the sample is small, the proportion is small. When the population is small and when the sample is small, student t-test, yes sir. Then it is always good for us to use t-test. Why t-test, Girish? Because it has been found that t-test very closely approximate the normal distribution as and when the sample size increases. That is a wonderful property of student-sized t-test. That is why we always use t-test. Now in t-test, we have a hypothesis. There can only be two things. Either whatever Girish has said is absolutely wrong, where beta 1 and beta 2, beta naught and beta 1 are zero. There is no impact at all. On the other hand, the alternative hypothesis said no. There is a significant change because beta is not equal to 0. So that is a null hypothesis and alternative hypothesis. How do I do that? You know this t-test. So this is a sample beta minus the hypothesized mean. Hypothesized mean is my assumption, and that is 0 divided by standard error of beta. Girish, what do you mean by standard error? Standard error is the standard deviation of the sample mean and the real population mean. It will tell us to what extent your sample mean or the sample result is genuine, authoritative, generic. Can it really be seen in the population? So in order to know that, we use standard error. Lesser the standard error, nearer will be your sample mean to the population. When mean itself is your friend, everybody will be your friends, especially in statistics. So that is why we use standard error. How and to what extent we do all that? Now you know this case of rejection, acceptance, etc., etc. If at all, if your beta value, your calculated beta, if it is really 0, then it will fall in this 95% range. And this is called as non-rejection region. This is a region where the real value of the population will definitely be 0 because the sample that you have got is also 0. So there is no significant relationship. Your beta, that is beta 1 hat, equals 0. That means your model is wrong. On the other hand, if it is, see, there are two ways. One is unidirection or two-sided, one-sided or two-sided. If it is one-sided, 95 is purely your way. There are three ways in which level of significance can be fixed by the researcher. It has been told in yesterday's session. Generally in social sciences, we say that the level of significance is 95%. That means your answer will be same if you repeat it for 95% times, and you may go wrong only for the remaining 5% of time. That is called as level of significance. 95% is non-rejection area, and 2.5% this side, 2.5%, or 5% together is your rejection area. Please understand, if your t statistical value falls in this range, then null hypothesis is accepted. If it falls in this way, then your null hypothesis is rejected, alternative hypothesis is accepted. Accepted in the sense, when one's null hypothesis is rejected, alternative hypothesis follows. So that is what is the theory of hypothesis. Now, what I showed you was not the actual thing, because I wanted to show you the way in which the sample regression function works. The actual output of EViews is this. So now my EViews output is telling me, look, first beta naught. This coefficient is 28.6. Same, whatever you got in the last slide, same. Standard error reported is 0.7, very less. That means it is good. But is it significance? What about the t-test? Is it 0 or significantly different? T-statistic. It is 38.04. Girish, we are getting confused. Don't worry. What is the level of rejection and acceptance? The test critical value of t-test is 1.96 or approximately 2. If this value is within 2, then null hypothesis is accepted. If this value is beyond 2, then null hypothesis is rejected. That's most a simple thing. Level of significance at 95% is 1.96 cutoff value or test critical value. Girish, what is this? Sir, it is test statistical value. Not test statistic value, sorry. So test statistic value is 38.04. Test critical value is 1 point. Will you please explain t-test once again in short? Sumanji, it is as simple. T-test here takes into account your calculated x values or calculated beta value, and it also takes your hypothesized beta value. What is your hypothesized? Hypothesized means whatever is in your hypothesis. What is there in the hypothesis? B equals 0. So your actual beta value minus 0 divided by standard error. So how do you get standard error? You take standard deviation of your sample data divided by the square root of the sample size. Then you will get standard error. Girish, do we need to do that? Please don't worry. You will not need to do anything. Just code in all these things. The software will give you result. Only thing is interpretation. You need to interpret. Software will not interpret you. It will present. You need to interpret it. All right. Now, so look at the first one. Beta naught coefficient is 28. Is it correct? Is it genuine? Is it statistically significant? T statistic 38. What is the cutoff? 1.96. Again, sometimes if the cutoff rate is not known, you may get confused, you may forget. Don't worry, you have another thing called as p-value. P-value is our closest friend. Why? Look at this. At 5%, your cutoff rate is 0.05. Remember this. At 5%. What is 5%, Girish? The remaining value. 95% is your level of significance. 5% is your rejection rate. So at 5%, your p-value is always lesser than 0.05. So this probability value is telling you, if you plot this entire thing in a bell-shaped curve, where your coefficient value lies. Your coefficient value statistically lies in 0.00. That means it is highly significant. What do you mean by that? Means the average value of 28 is what is generally that can be found in all government college students. No problem. Girish, how can you tell it? Sir, I am not telling it. Statistics is telling it. Because I have got statistically significant result. You cannot question me. My t statistic is good. My probability value is good. Great. Okay, Girish, what about LMS impact? What is LMS? 10.06 beta 1. Beta 1 is 10.06. So for every 1 hour of X1, your rate of increase in marks is 10. So 10 marks will increase. You should always be very careful in measuring. Measurement of variables is very important. So 10.06 is the increase in your marks. Standard error 0.1, very less. What about t statistic? 54. What is the cutoff rate? 1.96. Is it statistically significant? Very, 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 very significant. How can you tell it, Girish? Probability value 0.00. Wow. So do you mean to say that I have successfully devised one of the most fascinating empirical model? What is your take about it? But I can decidedly say, yes, on an average in Karnataka, students' average marks without any influence is 28. If at all, if you introduce LMS, then their marks will increase by 10 whenever they increase their studying with LMS for 1 hour. So this is what is the model. Now the question is, has Girish's model passed? Is it a good model? Can it be taken to policymakers? What is your take about it? Now this is the climax. What is your take about it? Can you quickly answer, please? Performance model, sir. Reliability test. Wow, Kadar sir, super. We don't do reliability test here. Fine. Any other inputs? What do you say, dear friends? Is it a good model? I told you it has passed 2 tests. Statistic is highly significant. How is improve? How is improve LMS? No. I'm asking you this. Is this model good? Yes, Chayaji is telling yes. Naresh is telling yes. Sorry, Nusrat madam is telling yes. If at all, if I take it to policymakers, they will definitely if I take this model, then my policymakers will definitely kick me to the core. Why? Because it is not at all a model. Why? You don't have any base right now to decide. Who are you people to tell me that it is a good one or a bad one? Because remember, my dear friends, I deliberately misled you people, because in empirical research, we tend to decide on the basis of evidences. You should have asked me a question, Girish. Please give me some more evidences to tell us whether it is a good model or not. Let's check out the real actual output that I have masked from all these slides is not the real one, but this is the real one. Look, the actual output of eViews or SPSS, whatever, other than giving you all this data, will also give you various other information. The first and the foremost information that you people should always check is R square. Girish, what is R square? Coefficient of determination, which will tell you to what extent your variables are able to explain the variance in Y. Explained sum of squares divided by total sum of squares. So that is what is R square, coefficient of determination. How much should be the acceptable value? It should always be more than 0.9, 0.8 to 0.9. How much is R square here? 0.96. That means these 2 variables, the average value of Y and the X that I have selected, log in R's, are able to tell me the changes that have happened in the marks. So they are good. So the variance is explained. Fine. Is there anything else? Yes, there's another very important thing. Now, individually, the average beta naught is verified. Yes, beta 1 is verified. But when you club beta naught and beta 1 together in a model as such, is it a good model or not? And the answer goes here. Look at the F statistic and the respective probability value of F statistic. It is 0.00. That means your model is superb, fantastic. As per F statistics, your overall model is statistically significant. Look at the inference. Your model is statistically significant. Very good, very good, very, very good. But what happened to the disturbance term is this log in as completely, has it been explained? Has the entire value of y depends only on the log in hours? So you mean to say that if at all, if LMS is not used, do you mean to say that the students will fail? There may be other things that have not been explored. So where is disturbance term? Therefore, other than identifying all these things, we should move on to something which is called as residual diagnostics. And majority of the researchers, it's so unfortunate to acknowledge that once they fit in a regression equation, they don't do diagnostics. That is why with this intention, my dear friends, I cooked a particular model where you will come to know how dangerous it is to fit a model without verifying the residual diagnostics. So let's move on to the last aspect, which is called as residual diagnostics. But first, let us check out what is the effect of the residuals on the fitted model. Is your fitted model good or not? So this is what is your observed, and this is what is fitted by the model. This is the actual number that you have taken. Fine. This is what is fitted. If you plot it on a graph with the 2 standard deviation, so fantastic. Your explanations, your errors are within the boundary. That means your residual plot looks good. Oh, that means model is good. This is one way. Other than that, you have a set of formal tests that you have to apply, which is called as residual diagnostics. Why do you do that, Girish? Let's recall the assumptions. So what are the assumptions? Assumptions is these, whatever we discussed. Expectation of the mean should be 0. There must not be heteroscedasticity. There must not be serial correlation. And there must not be any impact of U on X. And U must be normally distributed. So based on these assumptions, we have developed the residual diagnostics. And we have to apply them one by one. All right? Okay. The first very important thing is test of heteroscedasticity. So test of heteroscedasticity will tell whether there is a whether there is a homoscedasticity in the model or whether the model is heteroscedastic, whether the residuals are homoscedastic or heteroscedastic. The intuition is very simple here. If at all, if your model has completely captured the information in the errors, then obviously the variance must be standard. There must not be variance which is completely different from one observation to another observation. That is, in other words, there must not be heteroscedasticity. So there is a test called as Bruch-Pagan-Godfrey test, where the null hypothesis is there is no heteroscedasticity. That is a null hypothesis. And the probability value that we get here is 0.12. That means the null is accepted. So my model has passed the test of heteroscedasticity. Now, what about test of serial correlation? Another very important term. The covariance between ui and uj must be 0. That you please recall that. That is called as serial correlation. There must not be a correlation between one error term and another error term. So once again, we use a test called as Bruch-Godfrey serial correlation, LM, Lagrange multiplier test. And the null hypothesis is there is no serial correlation. That is the null hypothesis. What about the result that we have got? The result that we have got is 0.00. That means the null is rejected and the alternative is accepted. Unfortunate. Very unfortunate. So my model has deliberately failed because it is showing that the errors are very, very, very highly related to each other. That means the independent variable that I've chosen cannot fully explain the variations that have happened in Y. That means, look at the inference. That means the exam performance of Y is not in any way completely depended on LMS only. So that is the inference that I'm getting. How, Girish? On the basis of serial correlation. Once again, dear friends, the same serial correlation is right away shown to you at the output itself, but generally we don't look at that. I request you people, next time whenever you do a regression analysis, look at the last term, which is called as Durbin-Watson statistic. Durbin-Watson statistics is a very popular statistics, whether it will tell you whether there is serial correlation or not. And the value should always be near to 2. What is the value that you have got? Durbin-Watson statistic value is 0.4. There itself your model is gone. Okay, so be careful with the DW statistic. Now, DW statistic, Durbin-Watson statistic will tell you that the output that you have get should always be equal to 2. That means there is no serial correlation. If at all, if the DW statistic that you get is somewhere with a 0 or up to 1.1, then there is positive autocorrelation. So reject H0. So that is DW statistic. Another very popular test of serial correlation. All right. The last test that we have to do is we have made an assumption that the error terms are normal in nature. So we have this last test called as normality test. So kindly observe this normality test, and I want you to observe on this. So this is the test statistic that we use, which is called as Jarque-Bera test, a test which I'm very happy. Even you people should be very happy, because here Bera is our Bera. He is an Indian who is called as, wait, Dr. Shivkumar ji, please wait, Anil Bera. So this test is named after them, Jarque and Anil Bera. So there are several normality tests. Don't worry, there are several tests. One of the tests generally we use is test of normality. So what is the answer? The null hypothesis of this test is the data is normally distributed. So that is the null hypothesis. What is the probability of Jarque-Bera statistic? 0.25. That means it is more than 0.05. That means the null hypothesis is accepted. That also means that the data is normal. There is a normal distribution. How come you are telling it, Girish? Look at the two important moments in the distribution. One is your skewness and the other one is kurtosis. What is skewness that you have got? Minus 0.1, which is very close to 0. What is the ideal? Skewness should always be 0. Then what about kurtosis? Kurtosis must always be 3. Is it near 3? Okay, somewhere near 3, 2.21, acceptable. Therefore, we say that this data is normally distributed. So we can say that this model has passed this test. So what is the final analysis? The final analysis is model is ill-defined. Now, this is a classic case, my dear friends, where in spite of you getting significant results, model as such may not be a good fit. Therefore, just reporting your regression will not help you in any way. You must always do residual diagnostics. Now, what all can be done is we can use multivariate analysis. So without missing, please log in tomorrow, wherein for the first 10 minutes, I'll be showing you the regression results of multivariate analysis. And then I will move on to a fascinating world, which is called as time series analysis, where we model the time. With that note, dear friends, we have come to the end of day 1. I have tried my level best to simplify the most complicated aspects. And now I'll rest for question and answer session. Please feel free to ask me questions. And what about tomorrow? Tomorrow I will continue with not the same topic, but based on the same topic, I will introduce the concept of time series and how time series is modeled in commerce research. With that, thank you all being such patient listeners. I'm open to questions now.
Thank you very much, sir. Participants, you may ask questions. You can unmute and ask questions, or you can send the questions in the chat box.
What is control of the model? No, we don't have any control of the model. Remember, it is econometrics. In econometrics, we use econometric modeling. And in econometric modeling, it is always probability that will be taken into consideration. So we don't use any control function at all. Now, that is the beauty of econometric modeling. Okay, any other questions, please? What is Lagrange multiplier? Sir, Lagrange multiplier test is a test that is used in econometric modeling. It is not only in this particular whatever tools that I said. It is a way in which the calculations are done and the way in which the data is, the result is presented. So that is a term that is used in regression. Lagrange multiplier test. An estimation technique. Anything else?
Participants, any more questions?
Please share slides if possible. Thank you. Yeah, I'll definitely try to do that. Will you please share your mail ID? I will share my synopsis. Yeah, sure, no problem. It's very simple. Whatever you are looking at the screen, you just add these two, small letter G and small letter A, Girish Aradhya, add @75@gmail.com. My email ID is as simple as I am. What is multicollinearity? That will be explained by me only if you attend tomorrow's session. That's a concept, my dear friends. Forgive me and pardon me if I have been informal with you all. In case if I have exceeded my limits, it's only a humble attempt from my side to make the session simple and lively. Over a period of time, I have observed how the speaker's attitude affects the understanding of the participants. As I told you, I believe in simplifying things. My great gurus have simplified things. Yes, recorded session in the sense, I think we have to ask the organizers.
Yes, we have recorded the sessions.
Thank you, ma'am.
Available on YouTube.
Yes, it is there.
Any more questions? The participants quickly ask.
How to we make better KLMS model to accept to policymakers? Shruti ji, please attend my tomorrow session. You will get answer to it. Could you please explain how data is entered on eViews? Rajesh Ahuja sir, if at all, if time had permitted. Okay. Organizers, do I have 1 or 2 minutes?
Okay, sir. Okay. You can go ahead.
Okay.
Yes, please.
Okay. It's for the benefit of Rajesh ji,
Yeah,
I suppose. I am sharing this.
Okay, sure. Sir.
But tomorrow I'll share more about it. I'll actually show you this. So this is what is called as the eView software. What I have done is I have imported a particular data set. Data set here means, as I told you, I have cooked. I have a generated model, which is called as data simulation. In Excel, we use a function called as rand between, RAND, rand between. We can get anything and everything. And this rand between is same in Excel, in SPSS, in R. We can get any data with the things that we need. So I wanted certain defects in the system, in the model. Therefore, I cooked up the required one and I have given a name of this. So I have taken these many variables. Now, how we can do it? How to estimate equation? Very simple. Go to estimate equation. Simple. So here I have to actually type that population regression function. What is my dependent variable? It is exam performance. So it is exam performance. I have a C, that is beta 0. I have included the term beta 0. I'm telling the system calculate the alpha value. And then I have included what is my beta 1. Beta 1 means what is X1? KLMS login hours, right? So KLMS login hours. Okay, that's all. Run. You got the result. This is what was shown to you in your previous slides. See, your average value is 28 marks. Login hours effect on your average marks is 10.06. T statistic is this, probability is this, R square is this. How do you do residual diagnostic? Oh, very simple. Go to residual diagnostic. Whatever you want. You want serial correlation, you want correlogram tomorrow, you want normality test, you want heteroscedasticity. Do it. That's how. So that's how we do it. Tomorrow I will be doing it once again with you all, provided you all attend it. Tomorrow is a festival in for Hindus in southern India, and for all Muslim, I suppose, yeah, it's tomorrow itself. There was a confusion. So if possible, try to attend the session. I'll be doing it on time series. So with that note, I think same here. All right. I think over to you, madam.
Okay, sir. Thank you very much, sir. Good evening to all. Today is the 4th day of International FDP on Advanced Methodologies for Contemporary Research. We got an opportunity to listen to Professor Girish N, Assistant Professor of Commerce and Management, GFGC, Frasertown, Bengaluru. Before we could thank him, a lot of appreciation is flowing to sir on the chat box. Sir. Girish sir has highlighted on the various aspects relating to empirical modeling and applications. Application of appropriate tools and techniques are very important to make research successful. I'm sure that the participants got an insight into the same about the different models. Sir, it was a wonderful session and very informative and interesting, and you have given the details, very informative answer. Thank you very much. On behalf of the principal staff of Government Ramnaran Chalaram College of Commerce and Management and the organizing team and the participants, we extend our sincere thanks to Professor Girish and the resource person for sharing his experience and expertise with all of us. Thanks a lot, sir.
Thank you.
I would like to thank our beloved principal, Dr. Chandrasekhara B, who is supporting us in all our activities. Thank you very much, sir. I also thank the organizing team members, organizing secretary, Dr. Ejaz Ahmad Khan, Dr. Prahlad Chaudhary, IQAC coordinator, Dr. Satish HK, Dr. Natraj, Dr. Narsimharaju, Dr. Prakash M, Dr. Sri Lakshmi K, Mr. Hussain, Mr. Syed Rahmatullah, Dr. Shweta Kalman. Good evening to all of you, and thank you once again all the participants, and your participation is expected in the same manner in the coming sessions also. All of you stay safe, and we shall meet you in tomorrow's session, and we are lucky to listen to Professor Girish BN once again tomorrow, same time 2 to 4 on applications of time series in business research. Thank you so much, sir, for spending your valuable time with us, and we look forward for more and more interesting sessions from you. Thank you, sir.
It's an absolute privilege. Thank you.
Shall we conclude, sir?
Yes, sure.
Okay, participants, the feedback link has been sent in your...
A small request from my side, my dear fellow participants, my friends, kindly give your opinion, your feedback in other various ways by which we can, or I can improve the presentation. Please point out on the errors. In case if I have involuntarily have done something that may have irritated you, nothing personal, kindly point out your observations. I can always improve on the model and that will be based on evidences. Thank you, madam.
Yes, no, the time constraint is there. Within the minimum time, you have provided the maximum information, sir.
Thank you.
So thank you very much. So dear participants, please fill in the feedback form. It is sent in the chat box as well as in Telegram group and WhatsApp group. And we'll be waiting for you tomorrow at 2 o'clock. Thank you all. Stay safe and happy festival.